Next, we talk about the payback period. The payback period is the number of years it takes to recover the initial cost of the investment. If we take a simple example where the initial investment is 100, then you get 30, 30, 30 and 30 over the next 4 years. What is the payback period? By the end of year 3, you have recovered 90. By the end of year 4, you recover 120. Clearly, the payback period is somewhere between 3 and 4 years, but what is the precise answer? What you need to do is the following. You need to recover 100. To go from 90 to 100, that is another 10. What you assume is that between 90 and 20, the 30 is coming in continuously. So if the money is coming in continuously, how long will it take to get 10? The answer is 10 over 30. So the total amount of time that it will take to recover is 3 years and 10 over 30, or 3 and 1/3 of a year, or 3 years and 4 months. What are the advantages of the payback period? As you saw, it is very easy to calculate, it is easy to explain. It's an indicator of a project's liquidity. If you have two projects, one with a liquidity of say 3 and 1/3 years, and B which has a payback period of say 6 years, clearly A is more liquid because we get our money back faster. What are the drawbacks? This method does not consider cash flows after the payback period. Therefore, it doesn't really tell us about the profitability of a project. We might have a situation where project A finishes at the end of year 4. With the $100 investment, we get a total of 120 in 4 years. With project B, even though it takes longer to recoup the investment, but it is possible that after the payback period, we get 5 times more than the initial investment. In the payback period, the amount that we get after the investment has been recouped is ignored. So it is a very poor measure of profitability. Does not consider the time value of money, and this method also does not consider the risk of a project. The discounted payback method, this is fairly straightforward. The discounted payback method uses the present value of the estimated cash flows. It gives the number of years to recover the initial investment in present value terms. To come up with the discounted payback period, we need the discount rate. Let's say that's 10%. And if we go back to the same example where the initial investment is 100 and then 30, 30, 30 and 30, rather than simply using these numbers, we have to use the present value equivalents of these numbers. The present value of minus 100 at time 0 is minus 100. The present value of this number would be 30 divided by 1.1, then 30 over 1.1 squared, 30 over 1.1 cubed, and 30 over 1.1 to the power of 4. To come up with the discounted payback period, we use these numbers, and we'll make you practice a question on the next slide. The drawbacks, again like before, this method does not consider any cash flow beyond the payback period, and it is therefore a poor measure of profitability. Given what you have just learned, I want you to come up with the payback period and the discounted payback period, assuming a rate of 10%. Here is what you should come up with. For the payback period, we take the undiscounted numbers. Investment is 800 and then 340. At the end of 2 years, we have recovered 340 plus 340, which is 680. End of 3 years, we have recovered 102. 0. The payback period is between 2 and 3 years. To come up with the precise number, we say 2 plus 120. 120 because from 680 to 800 we need another 120, divided by 340 because that's the amount that we are getting over the third year. So the correct answer is 2.35. That is our payback period. Discounted payback. The initial investment is 800. Then, as we saw on the previous slide, we have to take each of these numbers and come up with their discounted value or their present value. The present value of 340, the first 340 is 309. The present value of the second 340 is 281. We came up with this number by saying 340 divided by 1.1 squared, and then 255 is 340 divided by 1.1 cubed. So step 1 is coming up with this row which gives us all the present values. Then we come up with the cumulative numbers. At the end of year 1 we recover 309 in present value terms, end of year 2 590, end of year 3 845. 845 is simply 590 plus 255. Here again we notice that we will recoup the 800 somewhere between the end of the second year and end of the third year, or in the third year essentially. To come up with the precise number, we say 2 years plus 210. Where is this 210 coming from? It is 590 plus 210 gives us 800. So 210 divided by 255. 255 is the difference between 845 and 590. So the discounted payback period is 2 and 210 over 255, which is approximately 2.8. I hope this is obvious to you, but the discounted payback is always going to be greater than the payback period as long as we have a positive interest rate. If the interest rate is 0, then the discounted payback and the payback would be the same, but that is very unlikely. Next we come to the average accounting rate of return. This is seldom used, but it is mentioned in the learning objectives, so we need to understand this measure. The average accounting rate of return is the average net income divided by average book value. If you have a project, and for this particular project over a 3-year period, we compute the accounting income every year. In period 1, the accounting income is 10, period 2, accounting income is 20, and period 3, the accounting income is 30. In terms of book values, let's say that the book value is 110 at the end of period 1, 120 at the end of period 2, and 130 at the end of period 3. The calculation is straightforward. Average net income is 20. So 10, 20 and 30, average number is 20. Average book value is 120. So this gives us our AAR, or average accounting rate of return. The decision rule between multiple projects would be to pick the project with the highest AAR. As you notice over here, this method violates one of the principles that we talked about, which is that we should use actual cash flows rather than accounting numbers. Therefore, this particular method is not too important, but you should still know that it exists. Profitability index. Profitability index is the present value of a project's future cash flows divided by the initial investment, and there are two formulas that are mathematically identical. Let's take a simple situation where you invest 100, so that's the present value of your initial investment, And then let's say that the present value of the future cash flows is 110. The profitability index is the present value of the future cash flows, which is 100, divided by the initial investment. So that would be 110 divided by 100. So that is 1.1. Notice that the second expression here is mathematically identical. Here we say that the profitability index is 1 plus the NPV. If your investment is 100 and the present value of future cash flows is 110, that means the NPV is 10 divided by the initial investment, which is 100. So here again we will get 1.1. The decision rule is straightforward. You invest in a project if the profitability index is greater than 1. A profitability index of 1 means that the present value of the future cash flows is equal to the initial investment. If the profitability index is greater than 1, then that means that the present value of the future cash flows is more than the initial investment. This is identical to the NPV rule. Do not invest if the profitability index is less than 1, and that is fairly obvious. Now, what is the advantage of this measure? Even though it's not used very often, but there is a basic principle here that you need to recognize. Consider two projects, A and B. In project 1, the investment is 1 million and the NPV is equal to 0.1 million. In project B, the investment is 1 billion, so it is 1,000 times bigger, and the NPV is equal to 0.2 million. With project B, the investment is 1 billion and the NPV is 0.2 million. If projects A and B are mutually exclusive, then purely based on the NPV rule, we would select project B because it has a higher NPV. However, we would be missing an important point. If you consider the profitability, then clearly project A is more profitable because the profitability index for A is 1.1, whereas the profitability index for B is just slightly more than 1, because for B we have in the numerator 1 billion plus 0.2 million divided by an investment of 1 billion. This number is just marginally more than 1. By coming up with the profitability index, we can see that project A is substantially more profitable. Next, we come to the concept of the NPV profile, which is very important. The NPV profile shows a project's NPV graphed as a function of various discount rates. The NPV is graphed on the y-axis and the discount rate on the x-axis. What I want you to do now is create the NPV profile for this project. Here is what you should come up with. At a rate of 0%, the NPV is simply based on the undiscounted cash flows. So the NPV should be 240. If you add up all these numbers and subtract 400, you should get 240. If you plug in a rate of 5% and compute the NPV, and you should be doing this using the calculator, you should get 167. So at 5% we come down to 167. At 10%, if you compute the NPV, you should get 107. And the NPV is 0 at a rate of 22%. There are some important points to note over here. The y-axis intercept is simply the undiscounted cash flows. To come up with these numbers, we simply plugged our cash flow into the calculator along with the relevant discount rate and came up with the NPV. This intercept on the x-axis is the IRR. If you remember the IRR definition, it is the rate which makes NPV equal to 0. On the x-axis, the NPV is 0. Therefore, on our calculator, if we simply plug in these numbers and compute the IRR, that will give us the x-axis intercept. So that's how I came up with this final number. What I want you to do now is the following. You are given two projects, X and Y. X is the one that we just worked with, and we also have project Y. I want you to draw the NPV profile for both projects. And just to get you started, here is the axis you need. NPV is always on the y-axis. The rate is on the x-axis. We already came up with the NPV profile for project X. Let's say that this is project X, where the x-axis intercept was 22%. On the same X and Y axis, I want you to come up with the NPV profile for project Y. Here is what you should come up with. The y-axis intercept is clearly 400, because if you look at the undiscounted cash flows, investment of 400 and then 800 at the end of year 4, if the discount rate is 0, then you have a NPV of 400. And very simplistically, if you calculate the IRR for project Y, you will get approximately 19%, and you just connect these two dots. If you want to be more diligent, you can also calculate the NPV at various discount rates. But from an exam perspective, knowing the fact that the y-axis intercept is based on undiscounted cash flows and the x-axis intercept is the IRR, that's what will help you a lot. Now, this point where the two NPV profiles cross is called the crossover point. The significance of the crossover point is that at the crossover point, the NPV of both projects is the same. So there is a particular rate which clearly is less than 19%, because 19% is the IRR for project Y, and you can see that the crossover is to the left of that point. So at this point, the NPV of both projects is the same. If X and Y are mutually exclusive, then which project is better? And the answer depends on the discount rate. If the discount rate is less than the rate associated with the crossover point, so to the left of the crossover point, then the blue project or project Y is better than project X. And to the right of the crossover point, according to the NPV rule, then the red project or project X is better than Y. According to the IRR rule, project X or the red project is always better. In our particular case, with a discount rate of about 10%, which is roughly over here, the blue project or project Y is better. Later we will talk about the conflict between NPV and IRR, which we have briefly identified over here. I want you to try this example now. Here is what you should come up with. In red, we have shown the NPV profile for the initial scenario. Investment is 200 and we get 80 every year for 4 years. If the discount rate is 0, then the NPV would be 80 times 4, which is 320, minus 200, which gives us 120. That is the vertical axis intercept. The x-axis intercept is the IRR. If you calculate that to the closest whole number, you have 22%. In blue, we show numbers assuming the improvements have taken place. The cost goes up by 30, so the project cost becomes 230. 360 is essentially the new cash flow, which is 80 plus 10 or 90 times 4, 360. With a zero discount rate, the NPV is 130, which is shown right here. So the vertical axis intercept moves up. When you compute the IRR for this cash flow, you should get approximately 21%. So the horizontal intercept shifts left. The correct answer therefore is A. Ranking conflicts between NPV and IRR. The point here is that occasionally the NPV rule will give you one result and the IRR rule will tell you to do something else. Whenever there is a conflict, you need to go with the higher NPV project. But let us look at this material in more detail. If you have a particular project with conventional cash flows, and if you recall, conventional cash flow means that there is only one change in sign, then there will be no conflict between NPV and IRR. In other words, if the NPV rule says that go for the project, the IRR rule will always say the same thing. If you have two projects which are independent and they have conventional cash flows, then again there will be no conflict between the NPV and IRR decision rules. We have a possible issue if we have two projects which are mutually exclusive, and this can happen even with conventional cash flows. It is possible that we can have a conflict between the NPV and IRR rules, and the conflicts can arise because of two possible reasons. One, there is a difference between the cash flow patterns, and two, there is a difference in the scale. Let's look at these items in more detail. Ranking conflict due to differing cash flow patterns. Consider two projects here, X and Y. For project X, we have a fairly stable cash flow over a 4-year period, whereas for project Y, we have the money coming up at the end. So clearly the cash flow pattern is different. What I want you to do is come up with the NPV and IRR for project X, and then the NPV and IRR for project Y. For NPV, assume a discount rate of 10%, and then you need to decide which project to select based on each rule. And just to take this to completion, also show the NPV profile for both projects. Here is what you should come up with. Based on the NPV rule, it clearly makes sense to select project Y because project Y has a higher NPV. But based on the IRR rule, it makes sense to select project X because X has a higher IRR. And again, when there is a conflict, the NPV rule is what you go with. Hopefully you recognized that we had done the same example before. When you come up with the NPV profile, you will notice that there is a crossover point, and I will not do that here in detail because this has been covered on an earlier slide. Ranking conflict due to differing project scale. Now we are looking at projects C and D. Notice that project D is 4 times bigger than project C. And here again, I want you to come up with the NPV and IRR numbers for both projects, and I want you to come up with the NPV profile. Here is what you should come up with, and notice again that there is a conflict between the NPV and IRR decision rules. NPV says go with project D, IRR says go with project C. When there is a conflict, you go with the NPV rule. And here is what the NPV profile looks like for both the projects. Now I want you to do this example. Notice this is the same set of projects that we saw on the previous slide. So here is the NPV profile for project D. Here is the NPV profile for project C. We are effectively being asked about the crossover point, because that's the point where both projects have the same IRR. So at what rate do we have a crossover? You can look at the two NPV profiles, and it should be fairly obvious based on looking at these two profiles that the crossover point is somewhere between 10% and 25%. So the correct answer is B. The multiple IRR problem and no IRR problem. When you have non-conventional cash flows, such as the numbers shown over here, where we have more than one change in sign, then it is possible that a project has either multiple IRRs or there is no IRR. What I want you to do now is come up with the NPV profile for both these scenarios. Here is roughly what you should come up with. For the first project, notice that initially the NPV is negative. It will rise, and notice also that we have two intercepts on the x-axis. So this project really has two IRRs. This issue is called the multiple IRR problem. With the second project, we do not have an intercept on the x-axis, and this is the no IRR problem. We can only have this issue when we have non-conventional cash flows. Now that does not mean that we have these problems for all non-conventional cash flows. It only happens for some non-conventional cash flows. Here now is a quick comparison between IRR and NPV. With NPV, the advantages are as follows. NPV is a direct measure of the expected increase in the value of a firm, and theoretically this is the best approach. As I have said several times, whenever there is a conflict, you go with what NPV says. The disadvantage is that the NPV does not consider the project size. And I go back to an example which I gave earlier, where project A has an investment of 1 million and a NPV of 0.1 million. Project B has an investment of 1 billion and the NPV is 0.1 million. If A and B are mutually exclusive, then based on the higher NPV, we would pick project B. But just looking at these two numbers does not tell us anything about the size of the project. With IRR, we get a sense for the return on each dollar invested, or in other words, if we know that the IRR on a project is 10%, we know that roughly we are getting a return of 10%. The IRR method allows us to compare the return with the required rate. If the required rate is 5% and the IRR is 10%, then this looks very good. We can say that the project is fairly profitable. On the other hand, if the required rate of return is 9.5% and the IRR is 10%, then we know that this project is only marginally profitable. Disadvantages, and here is a big one from a testability perspective. IRR incorrectly assumes that the money that is generated during the project is reinvested at the IRR rate. In other words, if we have a project where the required rate is 5% and the IRR is 10%, then any cash flows generated according to the IRR calculation are assumed to be reinvested at 10%. The theoretically correct assumption, however, and one that is used by the NPV method, is that intermediate cash flows are reinvested at the required rate. And it is because of this that we have issues such as conflicts between what NPV says and what IRR says. And that's the next point over here, that an issue with IRR is that at times it might conflict with NPV. The other issue with IRR that we just talked about is that we might have at times multiple IRRs or no IRRs, but this will only happen if we have non-conventional cash flows. Popularity and usage of the capital budgeting methods. In this section, we briefly look at which methods are used, which methods are more popular, and a nice summary is presented in table 13. This table gives an indication of the popularity of various capital budgeting techniques in different parts of the world. As a high-level remark, NPV and IRR are used quite a lot, but they tend to be more popular at large firms where the management has MBA degrees or other finance degrees. The payback method is also quite popular, especially at private companies. A larger point to note is that companies tend to use all methods. If you think about it, each of these methods tell us something useful. NPV tells us how much value is being added by a given project. IRR gives us a sense for the return that we will get by executing a project. And the payback period tells us about the liquidity of a project, how quickly we will be able to recoup our investment. Relationship between NPV and stock price. NPV is a direct measure of the expected change in a firm's value from undertaking a capital project. NPV is the criteria most related to stock prices. A positive NPV project should cause a proportionate increase in a company's stock value. These concepts are illustrated through an example. Let's say a company is undertaking a project with expected NPV of 500 million. The company has 100 million shares outstanding and each share has a price of $50. What is the likely impact of the project on the stock price? If the project has an NPV of 500 million, that means that by doing this project, the overall value of the firm will go up by 500 million. Since there are 100 million shares, then on a per share basis, the increase is going to be 500 million divided by 100 million, which is equal to 5. And that means that if the share price is 50 before doing this project, then by doing this project, the value can go up by 5. So from 50, the share price is likely to go up to 55. This is an extremely simplistic example, but the point is to illustrate the fact that positive NPV projects have a direct impact on share price. That brings us to the end of the reading, a summary of the main points. You need to understand the capital budgeting process. We discussed this briefly at the start, where we need to come up with ideas, identify projects, select the profitable projects, and then consider the strategy of our company to identify the particular projects that make sense. You need to be on top of NPV calculation and NPV rule, which essentially says that you select positive NPV projects. If you are selecting between projects, i.e. you have mutually exclusive projects, then you select the project with the highest NPV as long as the NPV is positive. You need to know the IRR calculation, and actually when I say calculation over here, you need to know the concepts behind the calculation, but you need to be able to do the work on a calculator. Make sure you are an expert at using the calculator. The IRR is that return which makes the NPV of a project equal to 0. IRR rule is that you select projects with the highest IRR as long as the IRR is greater than the required return. We talked about several issues with IRR. When you have mutually exclusive projects, then there are times where the IRR and the NPV rule will give you different answers. That can happen because of differences in scale or differences in the cash flow patterns. Whenever there is a conflict, you go with what the NPV rule says. We also have the issue of multiple IRRs and the issue of no IRRs where there are non-conventional cash flows. As a subtle point, you need to recognize that the conflicts between IRR and NPV arise because IRR incorrectly assumes that any intermediate cash flows are reinvested at the IRR rate. The theoretically correct assumption is that intermediate cash flows are invested or reinvested at the required rate. You need to be comfortable with the NPV profile, recognizing that the y-axis intercept is the undiscounted cash flows, or it is based on the undiscounted cash flows, and the x-axis intercept is the IRR. Do the summary as always, review the learning objectives, do the examples. The examples in this reading are short and quite helpful. Practice problems are good. Make sure you do them very carefully. And as I keep saying, practice questions from other sources as well. That is it.